Up to this point, we've been dealing with single equations in two variables and how to solve them. Today we're going to look at problems that involve multiple equations in multiple variables, which we call systems of equations. This chapter is going to explore several different ways to solve these multivariate systems. Today we're going to focus on using substitution and graphing the equations in order to solve the system. So what exactly does a system of equations look like? Here you can see we have two equations, each with two unknowns. Solutions to these systems must satisfy both equations. The point 43 is a solution to the system that I gave as an example. Let's look at why that's a solution to that system. So what I do is I substitute the point 43 for x and y in each one of the equations, and if they check out, if both of them are satisfied, then we know that 43 is a solution. So first let's look at 3 times 4 minus 2 times 3, and we want to know, does that equal 6? Well, we get 12 minus 6, and that does indeed equal 6. So our first equation is satisfied. Now let's take a look at our second equation and see if that one is satisfied. So I have 2 times 4 plus 3, and I want to know if that's going to equal 11. So I have 8 plus 3, and that also satisfies this equation. So 11 equals 11. Now what happens if you don't know what a solution is to a system of equations? How do we find it? Well, the first method that we're going to look at is substitution. And just like you can substitute numbers in for the variables, we can solve for y in one of the equations and then substitute that into the other one in order to find x. So let's see what that looks like. Let's take our second equation and we're going to solve that one for y. So I get y is equal to 7 minus x. Now we're going to take what we just got for y and we are going to plug that in to that first equation for y. So that gives us 2x minus 3 times 7 minus x is equal to 4. Now we're going to solve this equation for x. You can see we've reduced the problem now. We've got one equation in one variable. We've got 2x minus 21 plus 3x equals 4. So 5x is going to equal 25, which means that x equals 5. Now that I know what x is, I can plug that back in up here. I can substitute in x and find out what y is. So let's go ahead and do that. Y equals 7 minus 5, which means that y is equal to 2. So our solution point then is the point 5, 2. And the last step that I recommend is take out your calculator, go ahead and plug in 5 and 2 for y in the first equation for x and y, and in the second equation plug in 5 for x, 2 for y, and see if this is indeed a solution to this system. Does 5, 2 satisfy both equations? And when you perform your check, you should see that yes, it does satisfy both equations. Sometimes when you're given a system of equations, you can see that it involves decimals. Well, one nice thing is that we don't have to work with those decimals. We can multiply both of these equations by 10 and therefore eliminate the decimals. So let's go ahead and do that. The first equation becomes 15x plus 8y is equal to 23. And our second equation becomes 3x minus 2y equals 1. Now we're going to go back and go through the steps we went through on the previous slide in order to solve the system. The first step then is going to be to solve one of these two equations for either x or y. So I'm going to go ahead and I'm going to choose this equation here, and I'm going to solve that one for x. So I get 3x is equal to 2y plus 1. Now I divide both sides by 3, and I get x equals 2/3 y plus 1/3. Now the next step is I'm going to take this equation in terms of x, I'm going to plug in the result up here in the top equation. I'm going to plug in for x. So I have 15 times 2/3 y plus 1/3 plus 8y equals 23. Now you can see I've got a single equation in a single variable, y. So I'm going to go ahead and multiply this out, and I get 15 times 2 over 3 is going to give me 10, because 15 times 2 is 30, divided by 3 is 10. So I've got 10y. 1/3 of 15 is going to give me plus 5, plus 8y equals 23. 10y plus 8y, we get 18y equals 18. So y is going to equal 1. Now I take my result for y and I put it into that equation, and that's going to give me my value of x. So x is going to equal 2/3 plus 1/3. So x is also equal to 1. So my solution point then is 1, 1. Now go ahead and take a second to double check if I substitute in 1 for x and 1 for y into both of these equations. Make sure that they are both satisfied by the point 1, 1. Now that we've looked at solving a system of linear equations, let's take a look at how to solve a system of nonlinear equations. So here I have the equation minus 2x plus y equals 5, and x squared plus 3x minus y is equal to 1. First thing I'm going to do is I'm going to choose 1 and solve it for y. So I'm going to choose this top one, negative 2x plus y equals 5. And when I solve that for y, I get y equals 2x plus 5. Now we take this 2x plus 5 and we're going to substitute that for y in the second equation. So I get x squared plus 3x minus 2x minus 5 equals 1. We can combine like terms, so we get x squared plus x minus 6. We're going to bring that 1 over. And that's equal to 0. So now can we factor this? Well, we've got 3 and 2 that multiply to be 6. So we have x plus 3 times x minus 2 equals 0. So x can be either -3 or 2. So now you can see how we're going to have two solutions to this system. -3 is going to provide us with one solution, and 2 is going to provide the other solution. So let's start, and we're going to substitute -3 back up here. So y is going to equal 2 times -3 plus 5. So that means that y, when x is -3, y is -1. Now let's go ahead and do the same thing with +2. So y equals 2 times 2 plus 5. So that means when x is 2, y is going to equal 9. So my two solutions are the point -3, -1, and 2, 9. Take a second, pause the podcast, go ahead and get your calculator, plug in -3, -1 to both of your original equations, make sure that your answer checks out, and do the same thing with 2, 9. Go ahead and plug in 2 for x and 9 for y, and make sure that both of your equations are satisfied. Okay, now that you've had a chance to go ahead and check over the answer for the last problem, let's go on to another nonlinear example. We start the same way. We're going to choose an equation, and I'm going to go ahead and choose this top one, and I'm going to solve that for y. So I get y is equal to 2x plus 3. Now we're going to substitute y equals 2x plus 3. We're going to put that in here for y. So I have 2x squared plus 4x minus 2x plus 3 squared is going to equal 0. So let's go ahead and square 2x plus 3 and see what we get. 4x squared plus 12x plus 9, and that's going to equal 0. So now I have 2x squared minus 4x squared. That's going to give me a minus 2x squared. I have 4x minus 12x. That's going to give me a minus 8x. And then I have a minus 9 equals 0. Since each one of these is a negative, let's multiply the whole thing by -1, and that way we can have 2x squared plus 8x plus 9 is equal to 0. We'll cut down on our chances of making sign errors that way. Just by looking at this, I don't see a quick way to factor it. So let's just go ahead and use the quadratic equation. So x is equal to the opposite of b, so -8, plus or minus the square root of b squared, which is 64, minus 4 times A times C. Extend that out. And that's all divided by 2A. So 2 times 2. So now I have x is equal to negative 8 plus or minus the square root of 64 minus 72 divided by 4. Now, if I look at what's underneath my radical, 64 minus 72, x is going to equal negative 8 plus or minus the square root of negative 8 over 4. So now we look at underneath our radical, we have a negative number, so that means that there are no real solutions to this system of equations. So that's how to solve equations algebraically. You can also look at the graphs of equations in order to look at the solutions. So if we look at this first graph, we can see that we have two lines, and they intersect right here. So the solution to a system of two lines we can see is one single point. So there's one solution to a linear system of equations. This next graph, we've got a parabola and a line, and the line intersects the parabola at two different places. So this has two solutions, and we can estimate those points. This first one is negative 1, 1, and this one looks like it is 3, 2. Now if you take a look at this last example, we've got a line and a parabola again, but our line doesn't intersect our parabola at all. So this is a case like the last problem we looked at, which is no real solution. Now let's go ahead and take out your graphing calculator, and let's graph this system and see if we can find the solutions to the system. So go ahead and solve this equation up here for y. Oops, didn't mean to open that. So let's solve this one for y, and you're going to get y is equal to x. So go ahead and put that line in your calculator, and then for the circle, you're going to need to go to draw, which you get to by hitting second and then program. You're going to choose number 9, and that's the circle. You're going to put in h, which is 2, comma, negative 1 for k, and for your radius, you're going to put in 3. And don't forget to close your parenthesis, and then when you hit enter, the graph over here is what you should see on your calculator. And if we look, there are 2 points where that line intersects our circle. The first one is negative 1, 1, negative 1, I should say. And the second one is going to be the 0.22. So using the graph, we've found two solutions to the system, negative x plus y equals 0, and the circle x minus 2 squared plus y plus 1 squared equal to 9. And before you guys go off and try some problems on your own, we're going to look at an application of this method of solving a system of equations. We have a small business that it takes $6,000 to start up initially. The unit cost of the product that we're making is $23.20, and the selling price is $35.20. We want to know how many units we have to sell to break even. So how many units do we have to sell to make at least $6,000? So let's go ahead and set up this system of equations. Our first equation is going to look at the total cost. And I'm going to call the total cost C. Well, what is the total cost equal to? It's the cost per unit times the number of units plus we have to add in our initial startup cost. So let's build our equation. C is going to equal the cost per unit, which is $23.20. The thing we don't know is how many units we need to produce. So that's going to be X, our variable, plus our initial cost, which is $6,000. Okay, now that we've got our total cost, let's look at writing an equation for how much money we're making. So the total revenue, I'm going to call R, and that is simply going to be what people are paying, so the price per unit, times the number of units sold. Oops. Okay, so now that I got that keyboard off the screen, let's fill in our revenue equation. R is your total revenue, and we said that's equal to the price per unit. We're selling our units for $35.20. And again, we don't know the number of units we need to sell, so that is our variable X. We're interested in breaking even. So that means we want our cost to equal our revenue. So that means if R is equal to C, our two equations then are C equals 23.20x plus 6,000. And the second equation is going to be C equals 35.20x. Now we can take this 35.20x in this equation, and since it equals C, let's go ahead and substitute that for C in our first equation. Then we get 35.20x is going to equal 23.20x plus 6,000. Subtract 23.2 from both sides, and that's going to give us 12x equals 6,000, which means in order to break even, we need to produce 500 units. Okay, good job everybody. Now we've got 4 problems here for you to go ahead and try. Look back at what we did for the sample problems. We've done problems like each one of these. And once you have finished those, you are done with your homework for tonight. Great job, and we will see you in class.